Welcome to this video on 1-mark questions from the chapter Polynomials. These are the 5 questions that we would be solving in this video. I advise everyone to pause the video over here and attempt the questions before viewing the video further. The first question says that if on division of non-zero polynomial p of x by a polynomial g of x, you get the remainder as 0, what is the relation between degrees of p of x and g of x? For the remainder to be 0, that means for g of x to be a factor of p of x, it is very important that the degree of g of x is the same as degree of p of x, or the degree of g of x must be lesser than the degree of p of x. For example, if you are going to be dividing x plus 1 by x plus 1, we know you get the quotient as 1 over here, and hence the remainder over here would be 0. X plus 1 is a factor of x plus 1. Another example for the same would be when you divide 6 by 3. 6 divided by 3 is 2, remainder is 0. Here also the degrees are the same. This is one case. Or we may even have degree of g of x is less than degree of p of x. For example, if we had x square minus 1 divided by x plus 1, we know x square minus 1 is same as x plus 1 into x minus 1. And here you are able to perfectly divide, which means the remainder is 0. But let's say degree of g of x was greater than the degree of p of x. In this case, if you are dividing, let's say, x minus 1 by x square minus 1, you are going to get over here, while simplifying, 1 by x plus 1. It is not perfectly divisible. The remainder hence will not be 0. Therefore, the answer for this question would be degree of p of x must be greater than or equal to degree of g of x. Let's go to the second question. What will the quotient and remainder be on division of ax square plus bx plus c by px cube plus qx square plus rx plus s? This is quadratic and you're dividing this by a cubic. Whenever you divide a polynomial with another polynomial whose degree is more, so if I'm considering this dividend as p of x and the divisor as q of x, and if I'm having degree of polynomial which is being divided, the dividend, as less than the degree of g of x, remember that in this case you would say that the quotient is equal to 0 and the remainder would be the same as the polynomial p of x itself. As an example, let's take the case where I'm dividing 6 by 6x. When I divide 6 by 6x, 6 over here is a constant polynomial and 6x is a linear polynomial. I could have multiplied 6x with 1 by x in order to get 6. However, 1 by x is not a polynomial term. And usually when we do the long division here, we want everything to be in terms of polynomials. 1 by x is not polynomial, so this is not possible. Now you cannot multiply 6x with any other term which will make it 6. Hence, we would say let's multiply 6x with 0. When you multiply 6x with 0, you would get 0 over here and the remainder becomes 6. So you can see that the quotient is always 0 in this case and the remainder is going to be the same as the dividend. This is an important point to remember. The third question. A teacher, after teaching the chapter Polynomials in class 10th, wrote the sum and product of zeros respectively on the blackboard to test the skill grasped by his students. Find out the polynomial that the teacher has in his mind if he had written 2 and minus 2 on the board. The simple question over here is find a polynomial where the sum is 2 and product is minus 2. That's it. All the remaining information has been given just to lengthen the question and maybe create confusion in few of your minds who may feel that this is an unfamiliar question. It's a simple one. Sum is plus 2, product of zeros is minus 2. What is the standard form of a polynomial when you have the sum and the product given? It would be k times x square minus sum x plus product. What do you get when you substitute the sum and product? You have k times x square minus 2x plus minus 2, which is the same as k times x square minus 2x minus 2. So these are the polynomials which the teacher had in mind when he wrote 2 and minus 2 on the board here for sum and product respectively. Your answers could be just x square minus 2x minus 2, or you could substitute k as any other constant value and find out different polynomials as well. Let's try out the next one. Zeros of a polynomial p of y is dash of the point where the graph intersects the y-axis. This is a polynomial which is in the variable y. You need to find out how many zeros does this have. You might be confused by the fact that the graph is given to be intersecting the y-axis, because the usual logic you have learnt is that to find the zeros of any polynomial, just find the points of intersection with the x-axis. In this case, the graph which I have drawn, you might have said that, okay, there are 1, 2, 3, 4. 4 points where it is intersecting the x-axis, and hence this would have 4 zeros. But the question is giving you points of intersection with y-axis. An important point to note over here is that the concept of finding the points of intersection with x-axis applies when the polynomial is in x. When the polynomial is in x, you are finding out the zero which is the same as value of x, which makes p of x is equal to 0. But here the question is asking for 0 of polynomial p of y. For p of y, the 0 of the polynomial would be value of y, which makes the p of y value 0. So to find the value of y which makes the value of p of y 0, you would need to check where the graph intersects the y-axis. And this coordinate over here would give you the 0 of the polynomial p of y. How do you find out the value of the 0? The x coordinate is obviously 0. So the 0 in this case would be the y coordinate, which is also called ordinate of the point. This becomes our answer. For the last question, we had if the sum and product of the zeros of ky square plus 2y plus 3 are equal, find k. What is the sum of zeros here? Sum of zeros is same as minus b by a, which is minus 2 by k. And product of zeros is c by a, which in this case would be the constant 3 divided by k. If sum is equal to product, it means we are telling that minus 2 by k is equal to 3 by k. Now remember, this is never possible because minus 2 by k equals 3 by k implies that minus 2k equals 3k or minus 2 is equal to 3, which is not true. So you would answer this question as no value of k makes the sum and product equal. That's it for today. Thank you for watching. Please like this video and subscribe to the channel. Do share among your friends so that more students can benefit from the questions discussed in the channel. Thank you.